Hello, hello. Hi. Stuart, come. We have an announcement. We have a very important announcement about Scenic City Summit, right? There it is. Who doesn't know what Scenic City Summit is? You've never heard of it. Never heard of it. Yeah? Well, Stuart's going to tell you what it is. Stuart?
Hey, everybody. And I got this so I don't forget anything. So Scenic City Summit is a tech conference. We're a month away. Oh. Scenic City Summit is a tech conference. We're exactly a month away. It's going to be Friday, August 17th at the Chattanooga Convention Center. Over 40 speakers, a lot of different tracks this year. We're trying to expand so that we can accommodate everybody. This year we have an event sponsor. It's Red Hat. And a really cool thing is the Red Hat Mobile Portfolio Center is going to be in attendance. It's an 18-wheeler decked out with the latest and greatest Red Hat open source tech, and it's going to be parked in Exhibit Hall C. So if you don't want to go to an event, you can actually just scoot over to Exhibit Hall C and see that. Also, we will have an after party at the Edney here from 5:30 to 7. It's going to be included in your ticket, which also includes lunch. The conference is $75 or $65 for groups of more. Hope you'll make it. It's a great event. It's our 3rd year, and we really think it keeps getting better and better. Thanks.
Anna, come up here. More announcements. See, we got one or two more anyway.
Hi, I'm Anna Sherman, and I run Codex X, which is the women's tech group in town. We're having a meetup. It's coming up August 22nd, so you've got a little bit of time to plan. It's open to everyone. We're just a supportive group for women in coding. We're going to be spinning up a Rails app and adding users and authentication and like a login and logout flow. So that's August 22nd. I think I made it for 6:30 on this floor somewhere. So hope you guys can make it. We're on meetups.
There you go. You guys need help with the clapping, I can tell. I'll help you. Let's see, what else? Oh, so at the end of Startup Week this year, there's going to be a conference here in town called Gig City Elixir, and it's about functional programming and Elixir as well, but you don't have to be an Elixir to come to this thing. An array of speakers talking about an array of topics. Doesn't matter what area of the field you work in. If you come, you're going to learn some foundational concepts and things like that that'll help you be a better programmer no matter the area you work in. So that'll be fun. That happens October 26 and 27, I think, last 2 days of Startup Week. Just keep that on your radar. Tickets are on sale. And I'm helping co-organize it, so that's why I'm here talking to you. One more? The Gig City Elixir? Yes, indeed. Registration, you have to buy a ticket. Tickets are $350 for the early bird. We have an array of folks flying in, some from actually out of the country. It's a world-class lineup. Like at least 4 of the speakers have given keynotes on various continents that aren't North America. So it's going to be a good one. Okay, so without further ado, we've got Zach McElrath here. And did I say that right?
McElrath.
McElrath?
Good.
McElrath?
McElrath.
McElrath, all right. I tried. Yeah, he's co-creator of Squid, among other things. And he's going to talk to us about caching stuff. So,
Yeah, that's right.
give a round of applause to Zach.
All right, so just for those of you guys who don't understand what the pun is on this, go watch or go listen to the 36 Chambers by Wu-Tang Clan. That's where this is from. Just saying. Just because I know a lot of people didn't get that, but anyway. Okay, so the first thing I want to talk about today is performance, because caching is a topic that only makes sense in the context of performance. So this is a common thing. People probably are aware of this, but latency numbers every programmer should know. First thing we got to think about when we're talking about performance is the scale, and we really want to think holistically about the big picture. Because when I say if a user is experiencing a performance issue, we need to think about that problem and break it down into what are the pieces that are actually contributing to the problem. Is it happening, where in the whole cycle of things that are contributing to a user experience is there a problem? So if you think about computing technology, when you're talking about stuff that's on the actual like CPU or on your motherboard, if you're talking about numbers there, you're dealing in the level of nanoseconds. And a nanosecond is so small, we don't really even have a good way of picturing that. Then you get into microseconds, which is 1,000 nanoseconds. Then you get into milliseconds, which is 1,000 microseconds. And you go beyond that. So milliseconds are 1,000th of a second. Now we're getting into a human scale where we actually can kind of understand what that means. But if you think about all these, look at which one is on the bottom. The one, the very, very lowest, the one that takes up 150 million nanoseconds, is sending a network packet from California to the Netherlands and back. Go a little bit up there. At the bottom, you see disk reads, reading from directly from 1 megabyte from disk. That takes substantially less than a network traffic, but it's still at the scale of milliseconds. Going a few bit above that, you get to reading from memory, which is down back in the microseconds. So it's way, way less, order of magnitude faster. But these are still, these numbers are pretty hard to deal with, so let's take that into human scale. What is cache references? If we multiply this by an order of magnitude, we start getting some ideas. So dealing with cache in your underlying chips is the scale of a heartbeat, making coffee. These are operations that are much more lower level in your deep down in the computer. Going up a little bit, talking about referencing an item in memory from a piece of code, like in C or something like that. That's the level of brushing your teeth or trying to do a zip compression on your computer, getting to hours TV show episode. Now let's start talking about just network traffic. We're just going to send some really, really tiny payload over a gigabit Ethernet network. So notice the scale of these things. Now we're talking about half of a day versus a heartbeat. So let's go a little bit higher up. We're finally getting into the scale of reading from memory. So it's a whole weekend to read from memory, or reading from a solid state drive, reading 1 mega data. It's a week of spring break and a week of fall break. Okay, now reading from disk. The length of making a baby and the baby growing up in a womb. That's how long that takes. Okay. Not the making a baby, that's just kidding. Yeah, I'm just gonna throw that in there. So now let's go to the last one. Now we're talking about 4.8 years to send a packet from California to the Netherlands and back. Okay, the time it took you to go to college, unless you did the 5-year plan. Well, actually, almost that. So there's this huge difference in scale here. So if someone says, we're going to improve performance by swapping out the chip, I was like, okay, was that really the problem, or did you make a network request? One network request for one file. That might be a huge, so this is probably one of the original things that sparked this. A guy, Jim Gray, made a presentation. He was in Seattle, and he was like, okay, let's talk about reading from disk versus going to cache in memory on my computer. It's like, okay, let's get out of this, go to the room, moving to the hotel. Oh, let's go to Pluto. That's reading from disk. You gotta think about it. These scales are massively different. So how do the fundamental question is, how do I improve the performance of my web app? But I want to say that this really doesn't just apply to web apps. It could be my web of microservices. You might have a whole network of microservices you're orchestrating behind the scenes when you hit a server endpoint. And they may all be connected via the network. That's the fundamental way that different endpoints are connected, is a network. So it applies not just for browser to server operations, but also from server to server. These problems all involve network, and network is real. So is the solution to change your frameworks? Well, I drew a red line through it, so I'll let you figure out what that means. I'm just going to put that out there because a lot of times people are like, oh, we need a better framework. Our framework sucks. It's like, Does your framework suck, or are you making a request to it that takes as long as it takes to go to college? Like, I mean, just no, seriously, like, I don't care, like, frameworks, there are reasons to change frameworks, but Elixir, Node, Rails, there are all these frameworks. The fundamental issue is network. Think about that. Just make sure you're solving the right problem. Make sure you're, like, there are reasons to change frameworks. That's not the topic of this thing, though. But let's just say right here, network requests are bad. They're not bad because they give you something that people want. But if you're making too many of them, or if you're making things that you don't need to make, that's going to kill your app's performance, or your microservice network's performance. So what I want to say is, don't just guess. Don't just say, oh, I think this is going to be a really bad problem. Don't just say, I think. Go look at some data. Measure and figure out where the problem is. But before you can do that, you got to say, well, what am I trying to improve? What's my goal? You got to ask that question. Is it just time to page load? There's a lot of APM tools, performance tools that say, how long did it take me to load my page? Well, I'm going to say that's not really about page load. It's about the time to an interactive experience. That's a common metric people deal with. And here's kind of like a summary of what's that mean? Like, when you look at you're on your mobile app and you load a website and you see this little gradient with some images, I would say that's not a meaningful experience, but it's a page load. There's a page. There's some content on it. Can you do anything with it? Does it tell you anything? No, it's not meaningful. Can you interact with it? Can you read it? Is there content there you want to read yet? No. So a lot of web apps today, to compensate for performance issues, will do things like stenciling. They'll put in a little like placeholder that looks like content, but that is actually pretty useful because the user is not feeling frustrated yet because there is something they're looking at, but it's not a meaningful experience yet until there's like actual content they can read or begin to parse mentally. And it's not interactive until the user can actually click on it, start entering text or typing, and not have that content be blown away or disappear when more content loads. So you really got to think about which of these are you trying to optimize. You got to answer the right question, ask the right question, and then say, what do I care about? Because if you try to optimize for how to get the first paint, well, like if that's not really where users are frustrated, then you're answering the wrong question or solving the wrong problem. So let's just, really high-level factors affecting performance. Network speed and latency. It's a big one. Not just on mobile apps, but desktop. You may go to a desktop thing that's loading 300 network requests, and it doesn't really matter if you have a gig network. You're loading 300 different things from a bunch of different servers. It takes a while. You're loading a 1 megabyte JavaScript file. You have lots of libraries. Libraries are getting enormous, and people are using lots more of them. The problem is real. So yes, your hardware. If you're using a Commodore 64 to access the internet, you're going to have problems. But now some other things are cache. Well, we're going to get into caching, but which cache your resources are coming from and how long your resources are in cache, or are they cached? We'll talk about that. It's a problem. Actually parsing JavaScript. Believe it or not, it takes time. It takes finite time. Most people think, oh, I got the file, it's loaded, it's good to go. No. Sometimes you have the file from cache and it still takes your browser a while to do anything. Why? Because there is time that it takes to parse 2 megabytes of framework 1, framework 2, framework 3, framework 4, and all my code that actually uses those frameworks. It takes time, and the libraries are getting more and more complex. Your browser still has to parse it. Okay, so let's talk about cache. Here we go. All right. What is a cache? The whole idea of a cache is basically just storing data so that future requests for that same data can come faster. That's the whole idea. You can implement this all across the stack of computing. Everything. I mean, you can implement this in your life too, having a chocolate stash or a chocolate cache at home, so you don't have to go to the store to get more. But the whole point is, in network and computers, it's trying to store something. But the fundamental issue with caching is where does that come from? What is in that cache versus what's the source of the data? The data might be the result of an earlier computation that you've done. Like, let's say that you're trying to crunch numbers for Facebook, and you've got 1 million followers, and you want but you've got billions of users, and you have to, Facebook is not making real-time queries to everything to give you those numbers. They're caching a lot of things. Otherwise, they would be running queries against a billion record databases all the time. No, a lot of the stuff you're seeing is cached. Earlier computations to surface it to you. Or it could just be a straight-up duplicate. It could be not a compilation, but a straight-up duplicate of data that's somewhere farther away. So you're trying to bring data closer to where the user is that needs that data. That's what cache is. So where do I start when I'm trying to figure out how do I do caching? Let me give you this. This is your best friend ever. When you're doing web apps, the Chrome console or a Fireworks console. I like the Chrome console better, but they both do amazing, amazing things. These things could be sold as apps, except that they're free. But these are extremely powerful tools. And I'm going to focus today. I'm actually going to go through some things in the network console for the Chrome Inspector. This is one of the best places to start for evaluating web app performance. Once you get beyond the level of the client, you get to the server. The Chrome doesn't know what's going on in your server. That's kind of a black box. You have to start introducing new tools to say, once I hit Airbnb.com, what all made it take as long as it did? Why did it take 646 milliseconds to load that page fresh? Like, what happened in the server that made it take half a second? Which is a long time. The user starts noticing that after about 100 milliseconds. 100 milliseconds, the users start being able to perceive differences. There's lots of different things in them. I'm not going to talk about those, but each of these entries that your browser makes is a separate network request, and they all hit a server somewhere. So we'll talk about different places, but the biggest thing I'd say is focus first on the low-hanging fruit. When you're trying to do performance, there's a lot of really hard things to solve, and there's a lot of things that are really easy. And performance, it's always best with any problem to solve the low-hanging fruit first. Focus on what are your biggest issues, what are the things I can solve quickest or most easily. Okay, so I'm going to talk first about HTTP cache headers. This is kind of where with web apps this is kind of ground zero for caching. Number one, most important cache header is cache control. And the cache control header really, you have to understand it's solving three different problems. It's asking three questions. First, is the resource you're accessing reusable? Can I, as a browser, go to this resource, fetch it, and then when the user goes back to that page, if I have it locally, am I allowed to safely just use what I already know about? Can I just serve up this image file or this JavaScript file that's the React library or this CSS file? Can I reuse that without going back to the server? Hugely important question, because if the answer is yes, network request has been eliminated. You have saved yourself and the user huge amount of time going through a bachelor's degree. So if we can reuse this resource, we're saving ourselves tons of time. Now, another question that cache control answers and provides you the control over is, can an intermediate cache this resource? So between my computer right here and a server that's giving me a resource, such as Airbnb.com, there are lots of routers. There are lots of places that are in the middle that I might actually get to. And Airbnb may have said, I don't want you to go to my server on AWS to serve up this. I want to get it to you faster, because that's located in Northern Virginia or wherever. I want somewhere that's located in EPB's office building to give you a result for that file. That's possible using intermediate caches, or we call them CDNs, some content delivery networks. It's somewhere closer that can give me that resource that says, 300 people in Chattanooga in the last 5 minutes have asked for Airbnb's website or Netflix.com. They've all asked to watch this new show on Netflix. Well, I'm not sending you to AWS West Coast. I'm going to give it to you because that video is located in EPB's office over there. I'm going to serve that to you because it takes way less time for you to get it and doesn't overwhelm AWS West Coast. It's an intermediate cache. Now, the source of this, whether it's Netflix or Airbnb or whatever, has to tell the browser and those intermediate caches that it's allowed to do that. It doesn't happen automatically. If you don't tell it that it's okay to cache that, it's not going to happen, and you're missing that opportunity to save your users the distance from EPB to the West Coast. That's a lot of wasted time, and it's one header that can make that happen. So it's an important header. And then the next thing is how long? How long is it safe to cache this resource before I have to go check and get a new version? So it's roughly this basic decision tree. Like, I get back a resource, and the browser says, is this reusable? Well, if you send cache control no store, that base tells the browser and intermediate caches, no, don't even think about it. Don't forget about it. Don't cache this thing. No way. Maybe it's private data. Maybe it's really sensitive, like user information. It's a lot of stuff that should never be cached. Really important question. So if they say yes, okay, you can do that. If I want to be able to cache it, you can send the no cache is a little more complicated, but it just basically says like, yeah, well, I'm not going to talk about no cache. I'm going to skip that. Cache. You can also send private or public as in the cache control header, and that tells that basically determines whether somebody in a CDN or like EPB locally or another internet service provider resource can take a file like some Netflix show video stream and cache it there. If you say private, nobody in the middle is supposed to hold on to it. That means it's only for you. Your browser, or like just this Mac, is allowed to cache this thing from Airbnb.com. That's it. Nobody else in the middle in EPB or anywhere else can cache this. Your browser alone, for your eyes only. And then the next question that you need to ask is, how long can I cache it for? Is it for 2 seconds, 2 years? How long can I cache this before I have to go back to the server and do that again? So those are kind of the fundamental questions. The goal is to eliminate trips to the server. That's the college bachelor degree experience we want to avoid. We don't want to go there. We don't want to go to the server. We want to get it from our, if I can get a file on my Mac, that is instant, basically instant. I can render my web page with something I already have. We want to be doing that. Now the next stage beyond this is, if I'm trying to get a resource and the server has told me, nope, you can't just use what you already have. You have to come back and check with me first before you start safely using it. So this is where something comes in called ETags and another strategy. So let's say that I've got a resource and it does frequently change, but it's really large, like maybe it's I don't know, some image or some pictures, I don't know, something that you want to check a lot. You can send down something known as an ETag header that is kind of like a condensed hash of what that resource looks like, and that instructs the browser to say, okay, the next time I go back, I want to refresh this page and go look for that resource, I have to go check with the server whether this thing has been modified. If the server sends me a 304 not modified response, and then I don't have to re-download it. I can use what I already have. So that's accomplished by the browser sending up this, basically replaying the ETag, sending it back to the server and saying, hey, I've already got this version of my file. Is that okay? Can I go forward with it? The browser says 304 not modified. The browser's like, sweet, I'll use it. I'm not going to download anything. So this can be really good because it can eliminate a download. If it's a huge 1 gig movie, sweet, I didn't re-download that thing. Netflix told me it's the same. The show hasn't changed. That's great for videos and static content. Really, really good for static content, like videos and like images and stuff like that. I can eliminate that, and it can improve my performance. I can render my page quicker. I don't have to wait for a download. But there's a huge problem to this. You're still going to the server. You're still going to, whether it's Netflix, Airbnb, you're still going there to ask them the question, can I use this file? That's really inefficient if you go all the way to the West Coast and say, can I use this file? And they're like, yep. All right, I'll go back now. But meanwhile, the user is waiting 200 milliseconds or some time just to know, hey, the thing in my file is already good. So if you can eliminate that need to go back to the server to check, you've eliminated that time. That's really, really important. The other thing is the server may still have to do like a comparable amount of work to figure out if the thing has changed or not. So you send an ETag, you say, here's my hash of the resource. This server still has to go determine, has the resource changed? Now it may have some local cache or something that says, here's my timestamp, modification of my resources, But the server has to do some work, and we don't know. That's a black box to us. We don't know how the server is implementing that. It's up to the implementer. So if you can eliminate the need to go to the server at all, totally worth doing. OK, so caching sounds great. It's wonderful for static content. If you have a website where you don't really care if people have stale data, like, I don't know, it's displaying a business's website and it doesn't change very much, like, great, serve them. You can say cache everything and, for like minutes or hours or days, something like that. And the browser can load it once and then get all this stuff right off of the disk, right out of memory. No trips to the server required. But there are many resources that it's not OK if you get stale data for. If you get a stale, if you're going to Airbnb and trying to book a place, and they served you back a stale list of what's available, and you try to book it, there could be a server error, you could be really frustrated, or a stale, buying tickets. Stale data is often very problematic. I want to be the first in line to get a concert ticket. And they told me that they sent me an XML HHR request that said it's still available, and it wasn't available, so I'm super mad. Cache invalidation is really important. It's very, very important, not just for things like that, but also just in your web apps. If you've got a JavaScript library that you wrote that is expecting a certain server resource to exist or it be in a certain format, and you do a new deployment of your app, V1 goes out, V2 goes out, V3 goes out, V3 has a different server resource and you didn't version it or something like that, or you have different JavaScript files that depend on each other. If you serve the user if some of those files are stale and they're out of sync, you can get some really bad stuff. You can get one JavaScript file expecting something to exist that's not in the browser doesn't have it yet, or the server is out of sync. Having stale stuff can be really bad. It can break your apps. So here's the next big question: cache invalidation. So this is, everybody's probably heard this quote, but I love this. There's only two hard problems in computer science: naming things, cache invalidation, and off by one errors. Cache invalidation, I would definitely say naming things is hard, but cache invalidation is actually really tricky. And you have to, as soon as you start caching things, you get into a really dangerous spot, because if you serve somebody, you have to know, when do I bust the cache? And that's pretty tricky. So the question is, if the client still thinks it's OK to use it, how do we tell them that it's not OK to use it? How do we communicate that to the client if they're using a cached resource? If the browser's like, I can keep using this forever, well, there's a really easy way. Just tell them, do a hard refresh in Chrome, and everything will be up to date. Sorry, Grandma doesn't know what a hard refresh is. She doesn't even know what Wi-Fi is or how to, yeah, it's bad. OK. So how do we get the best of both worlds? Well, really, if you take one key principle for caching that you can use in your web apps, super, super helpful, this principle right here. Change the URL of the resource when the resource changes. That's it. Super, super, super important principle. If you are serving a web app and you have CSS, JavaScript, images, whatever it is, videos, if you change that thing on the server, don't change it in place. Distribute that under a new URL, a new resource identifier, so that when your browser goes, and then, so let's say you send out an index HTML page. I'm going to give you an example of this in a little bit, but the index HTML page can say, here's the URL to my resource. And the browser's like, I've never seen this thing before. It's myfile.v2.js. I've never seen v2.js before. I don't have that. I'm going to go fetch it. If you had kept the name, the URL the same, to be like, oh, I already have, myfile.js. I'm going to serve the local thing. Well, and you put a cache, you can never put safely a cache control header on a URL if you are ever going to change it. It is not safe. Do not do that. You will cause yourself and your users so much pain. Do not do that. Give it a new URL. OK. Before I jump into some more stuff, I'm going to go actually give an example of this, because I think this is kind of a core principle. I really want to show this. So I'm going to do a really simple example. First, I want to give you some overview of the Chrome Network Console, because if you get nothing else, I want you to kind of understand some basics of analyzing network. Okay, so I'm going to open the Chrome Network Console, Command-Shift-J or Command-Option-J, open it up. Now, for assessing performance, a really helpful thing is to do disable cache. This will tell you what happens if I'm going to a website and I haven't been there before. So let's first just see what this looks like. Okay, we're going to record it. All right, we're going to wait till I actually see something meaningful. So time to interactive is what I'm going for. Okay, let's stop right there. I got something I can interact with. I've got some stuff. Now let's drill into what actually happened here. So I'm going to back this out for a bit to let you see the waterfall. The waterfall on the right is all the different things, is kind of the flow of how resources are coming from the server. By the time you notice it's like going through time, down here I'm at about, where I stopped it was at, I think like 8 seconds. So, you know, it took a good while, a good 7-8 seconds before I got something that I considered interactive or meaningful. And this is on a, you know, consumer grade website. Now I want you to notice what's going into that. 171 requests. There's 171 network requests to show me Airbnb's site. Now, let's be fair. A lot of those are tracking garbage, but we're not going to talk about that. But 3 megabytes of data was transferred. That's a lot. 3 megs. Like if you're on a phone, that's a lot. I don't care what you're on. That's a lot. It takes time. Notice the initial request. 1.5 seconds to give me an HTML page. Okay, that's real. Like that's real time that the user is waiting. Users will often abandon a website after even a second. Like this is Airbnb. That's a lot. That's a long time. There is a ton of JS in here. There's a ton of CSS. Full 4 CSS. Okay, ton is an exaggeration. All right. There's lots of XHRs. Now, this is your friend because if you turn off the disable cache, now you can see something really important. Notice the times here. If I refresh this, I'm going to start seeing some much better performance. I'm getting, okay, timed interactive in like 2-3 seconds next time. The reason that is possible, I'm going to blow this up a bit, is because of this. These numbers right here. Now, notice the size. The size is gone. There are these little parentheses saying from disk cache. And if I refresh this again, it'll actually go to, I think it'll go into memory cache. 0 milliseconds. That is what we want. 0, 0, 0. I want my page. I want it now. I want all of its things right now. Memory. This is the holy grail. This is what we want. We want, if we could do everything from memory, you would have instant web apps, basically. JavaScript parsing time required, yes. But some things, notice in this page, some things are not getting in cache, which is very, very, very important. Specifically, the document, the HTML document that contains all of these script includes and CSS includes and image sources. This guy should not be cached. You cache that guy, that is only okay for static websites. You cache this thing on a website that has like content where staleness can be a problem, you are shooting yourself in the foot because your browser maybe can say, I'm going to keep serving you this old JS file that hits a server endpoint that I just tore down in my deployment. Oh, dang it. Okay, yeah, you don't want to do that. But everything else, yeah, you're getting really, really fast. Like this is coming super, super quick because it's coming straight from memory. And you can examine all this just by going to the network console. Very, very powerful. So now let's kind of break down some more detail. There's a lot of network requests here. I'm going to go something a little simpler. An amazing, amazing website that gives me a list of people from a database and lets me add a new one. It has 3 network requests. So much easier to think about. Okay. Here, this is just a basic little server. It's serving up one JS file that does some logic, and it fetches one file from my app. And notice it takes very, very little time because it's on my Mac. I'm cheating. Okay. If this was an AWS or something, it might take a couple hundred milliseconds just to get a response back. But notice here when let's turn off the cache. Okay. Oh, I think I did. Well, of course I turned off my web server. Let's turn that. All right, let's turn it back on. Okay. Now we got a thing. Helps to have a thing. Okay. So now I refreshed and disable cache, so I don't do anything. Okay. So I turned off my cache, pretended this is the first time I ever came to it. I got 3 status 200s. I didn't have anything in my local cache, so I had to go get fresh copies of all of these things. And you also notice the sequence. Because the HTML file initiates the load of the JS file, you can't start loading it until I get to, until the HTML file is downloaded. Now, I'll talk about, there are ways to eliminate that problem. HTTP2, we'll talk about that in a second. But this sequential nature of your network requests is very, very important for improving performance. If you look at your app and you think about all the different requests that are made, you're going to think, are it saying, why is it not starting this until 3 seconds from the time I launch the page? What initiated that request? Can I make that start sooner? Very, very powerful. If you can start certain things happening earlier, you can really speed up your page. If you're waiting to load an image until the page is basically all rendered, all the JS and CSS is there, and then you have this little line that says, hey, add an image tag to the DOM. Now the browser is going to start loading your image, and it's a meg. That's going to take forever. You could have had that thing preloaded 3 seconds earlier and sped that up hugely. So the timing here, when to kind of look for those patterns of like, oh, all of these things start here. Why are they not starting over here? I'd love them to start immediately. Look at the patterns of when things start. So mine's pretty basic. Load HTML, that loads a JS file. The JS file goes and fetches an XHR. That's basic, like, so there's very simple dependency tree. That has to happen, then this, then that. So now when I refresh this page, oh yeah, my database is doing some stupid stuff, but that's fine. So this next time, I got a 304 not modified. What happened was, let's refresh this again. Okay, so no cache. Let's go look at the headers. So the response coming back from the server, it told me, don't cache this thing. You can cache it locally, but you have to come back to me and check whether it's still good. That's basically what no cache means. You can cache it locally, but come back to me and ask me if it's okay, your silly little JS file. So it sent down this thing, this ETag. So the ETag header, the browser's going to associate that with the file and say, sweet, I'm not going to go, the next time I go back to the server, I'm going to send that. Let's refresh this. Okay, now in the request header, I sent this if none match. And so the server grabs that and says, sweet, I already got a file. Here's the ETag, matched it. It hasn't changed. You can keep using that file. Don't ask me, I'm not going to give it to you again. And the browser's like, sweet, I'll do that. So in here, notice the difference. You can tell that happened not just by the 304 not modified status, but also the size. This little gray bar down here says 1.8K. Here it says 292 bytes. That's because it took 292 bytes to send a request to the server that said, hey, here's the ETag. Has this thing changed? So it didn't send any data. It didn't send me a new file. That's the total size of the network traffic that went to the server and was like, has it changed? Nope. Great. OK. But this is the size of the actual JS file on the disk. That's why it's so much smaller. OK. Now, what I want to do, though, is I don't want to have to keep making this network request for that same file. Every time I refresh my page, I'm making that network request. I want to eliminate that. How do I do it? URLs. If the URL has a timestamp in it, and I send a cache control header to the browser can cache it forever, and it can cache it safely. Because if I need to go update that file and make a change, I can change the URL. And then the browser will have to go fetch it brand new. So let's see how I can implement that. So in my server, I have basically on server startup, I'm sending down I'm defining basically a timestamp of when my server reboots. And this is kind of an interesting pattern because you know that like when you do a fresh deployment of your app, you're going to have, like you might have new server controllers or new resources. So that's a good place, that's a good starting point for like a mod stamp to cache invalidation from, is your server restart time. That's one idea. So I'm sending down, and this is like a templated HTML page. So my server, when it starts up, just to give an example, I'm creating a mod stamp and I'm injecting this into the view processing engine so that it's going to have that as a context variable to use. So now I have a URL here that I want to, instead of fetching just js/app.js. I'm going to fetch it with a mod stamp in there so that it's so that I can have a new one later on. When I reboot my app, if I reboot, it'll send a new timestamp. So let's go to now the controller. If I just add this in here, mod stamp, now I have kind of a dynamic route path. I'm still going to serve the same file, but now what I'm going to add is I'm going to have my framework send a cache control header. I'm going to have it say you can cache it for 7 days, and you can public caches like EPB or my ISP can cache it. So let's do that. Save it. Now I should be rebooted. Okay. Okay. So now when I go here, I'm getting the resource from like JS/, and there's a timestamp in there. That's basically when my app start time. And when I refresh, it's coming from memory cache. Yay! I don't have to go to the server. It's my browser is, because I got this cache control header, max age, that tells it how long, 7 days, and it's public. Sweet. So if I keep refreshing this every time, for 7 days, it's never going to do that. But let's say I want to go add a new handler to my app.js. Okay. Oh, I got too many app.js's. That's a problem. Oh, static. Here we go. So if I want to add a new function, if I wanted to go, let's just say I want to add a console log. Okay. All right, I'll refresh this. Okay, now my server is going to restart because a file in the file system changed. This is going to create a new mod stamp. So I refresh. Now it's going to go get it from this 846. It's a different, and it's safe. Like I didn't have a stale JS file. It got a new URL, but now it's immediately caching that thing again. So memory cache. That's kind of a basic. That's a hugely important step for your web apps to have cache, but not be subject to stale data problems. So I just wanted to kind of give that kind of basic, really brief introduction to some of those things. Hope that was helpful. So last things I want to talk about are some other tools in your toolbox for web app caching. So as of, believe it or not, this technology, service workers, if you haven't heard about it, has been around for years, but it was only this spring in April that all modern evergreen browsers even supported it. Oh my gosh. It took Safari and Microsoft Edge only just supported this about 3 months ago. Okay, it's terrible. Even though this spec has been around for years and years, and Chrome's had it for years and years and years, and Firefox has. But it's very, very powerful. A service worker is essentially a client-side proxy that can intercept all network traffic and be able to do things like serve it from browser, or serve it from local cache, or I don't know, it could serve it from wherever you want. It's basically like you have a window into the network layer of your app. You can change where requests get responded to from. You can intercept the whole network traffic layer. It's very, very powerful. It can get very complicated, but it's a great way to implement some caching. You get one JavaScript file per your domain, so like airbnb.com/serviceworker.js. And the benefits are you can do, this is a great way to implement offline apps in the browser. You can make it so that the service worker fetches all the resources that would be needed for the app when offline, so that if the user goes offline, they will have them all. It also lets you do kind of an offline first design principle, kind of thinking, well, can I serve this whole app without being online? Do I need to go back to the server to get this stuff? The service worker can facilitate fetching all those resources for you. One of the great things it can do is pre-caching of resources that you know you're probably going to need. So let's say your app has, 5 different main areas, 5 different main pages or areas. If you know that your users are going to go to 2, 3, 4, and 5 in the next 10 seconds, your service worker can immediately kick off fetches for all those things. It can say, I'm going to go preload all that stuff for the other pages. Or it can start doing it piecemeal. Really depends on how your app's designed, but it can do this pre-caching so that when your user tries to go here, your browser's ready. It's already got everything you need. No time wasted at all. It's very, very powerful. And there's a lot of different, there's various different ways to do this in web apps. I'll give you an example. There's some other technologies you can use, such as DNS prefetching. Like Google, if you go to Google search and you go see a list of, you search for monkeys, and there's a list of 10 different results on 10 different DNS domains. When you go make a request, like when you go click on that first Google search result, your browser has to do DNS lookup to go say, where is that? What's the IP address of ilovemonkeys.com? And then what's the IP address of the 10 YouTube results for monkeys? I need to know where youtube.com is. There's something called DNS prefetching that will do, Google uses that extensively to do like preloading of DNS. So there's different ways to do preloading and pre-caching, but service workers are a great way to do this. It also lets you do very dynamic caching. So based on user patterns. So let's say a user clicks here, you say, oh, well, they clicked there. I think they're going to go here next. I'm going to go preload that resource based on the different user paths. You can do some really interesting stuff. Like the predecessor to service workers, something called application cache, which is deprecated in all browsers, but still supported by all browsers, which was basically like, here's a huge list of all the files you might never need while offline. One list. Same for everybody. There's a lot of problems with it. Service workers lets you get a lot more dynamic. Like, this user does very different things than this user does. I want to preload different resources based on the different paths the user takes. Now, service workers can get kind of hairy. There's a really cool tool called Workbox that Google puts out that will do dynamic service worker generation. It's kind of like it kind of figures out a lot of things. You can integrate it into your build process. So like you add new resources that you're generating with Webpack. It'll dump them into your service worker. So that's really helpful to not have these static service workers, because your service worker can be a source of cache problems. If you don't version that thing, your service worker can be down there in your browser and saying, hey, I've got that file. Hey, I've got that file. And you're like, no, that's the wrong file. My stupid service worker is, oh gosh, you don't want to get in that position. You have to make sure things like all these different tools, you have to consider cache invalidation. You can get into some really bad spots if you don't version your service workers and force them to update appropriately. There's also an interesting this is not supported in Edge and Safari, but there's a new emergent API that is like a really small subset of this. It's called just the cache API. Super basic, window.cache. You can add a cache result, put, delete, and do a match, and it will serve. It's basically just request responses. Super, super lightweight, and it kind of takes a small piece of what service workers can do, but also interesting thing you can implement. Now, before I end, I just want to throw I didn't talk about this, really there's tons of different dynamics to server-side caching. Like I say, like when I go to Airbnb.com and I fetch an HTML page, why did it take 1.5 seconds to load that? What all happened back there? There could be a whole lot of stuff. Slow or expensive database queries. You might want to prefetch or cache those in memory on your app server. You might want to do, I talked about CDNs, but a CDN is basically like a place that's closer to you than your web server that has the resources your users need. But you could do that for all kinds of stuff, like data results, your HTML page. You could implement something called a reverse proxy cache. It's kind of similar to the CDN, but basically just something closer that serves the same stuff instead of your server. Takes the load off of your server. And the other thing you might want to be optimizing server side is your network traffic. So you may have a whole microservice web. It's like this thing does this, but it needs this, that needs this, that needs this. All of a sudden, you've got network requests all over the place internally. And microservices are great, but if you don't have a good way of wrangling them, you might have a lot of network traffic that's going to slow things down server side. So one thing is, if all of your microservices are on the same, like, let's say you're using Kubernetes or something like that, if they're all on the same disk, basically, they're all on the same app server, that's not going to be as big of a problem, because the network requests, quote unquote, are going like literally next to it on the chip. Like, that's not very far away. Okay, that's really good. Don't have them all on different servers, different places. So another thing that's really powerful for the server is HTTP2, is a new protocol that lets you pre-send a whole lot of network requests when someone requests, say, your HTML page. So if I went to, let me just pull this up real quick on Airbnb's site. When I went and I fetched, let me turn off cache again. I'll show you this. Okay, now I'm going to stop it right there. I don't care about this. Notice the protocol tab you can turn on here. It says H2 or SPDY. Spidey is kind of like a precursor to HTTP2. But basically why a lot of these requests are happening kind of in tandem is because Airbnb is, when you go to the HTML page, it says, hey, you go to the HTML page, I know you're going to need these 20 files. I'm not going to make your browser wait to get that HTML page before I send them to you. I'm going to just send them along with the HTML file. It's awesome. So there's a lot more stuff to talk about there, but I'm going to just close it out. Okay, pop here. Now, I just want to end by giving you something to think about. Why does this matter? It matters for your users. It matters for your users because their time is at stake. But also, think about this. What is the total cost of the internet? 70 billion kilowatt hours per year. The study, Lawrence Livermore Labs did a study that in 2016, they kind of estimated. How much is that? That's twice the yearly output of all US solar panels. Like, how much does it take to run all the servers that power the internet? That's a lot. I mean, you may think that's tiny, but what can we do about that? Well, we can reduce network requests, stop hitting servers. We can use caching strategies. There's also something called the save data header. It's very interesting. For mobile apps and desktop apps, your browser it's kind of a common standard, say like, the user's trying to save data right now. I'm going to send them smaller resources, like smaller images. And you can, lots of interesting stuff, but I'll close there. All right, thank you guys.
Thanks, Zach. See you guys next week.
All right, anybody have any, I know it's right at time, but if anybody has any questions, you can either ask me or come by afterwards.